Okay, so again, we're starting with absolute value equations. So the first thing I want to talk about is what is absolute value? When I say the absolute value of a number, what are we talking about? It is positive, because we're talking about the distance from 0. Okay, so absolute value is the distance from 0. How far a number is away on the number line from 0. So here's my question. The comment was made that it's positive. Can you go in a negative direction? You can. I mean, even if I'm going backwards, aren't I going somewhere? Right? Okay. So I'm starting. It's when you talk about distance, you can't ever have a negative distance. It always has to be positive. So when we talk about absolute value of a number, it's always a positive distance from 0. Whether you're going from left or right, it's still you're going somewhere. Okay. So when we do the absolute value equations, the very first thing you want to do is you want to isolate your sorry, I'm trying to spell and talk at the same time. Isolate your absolute value. And what I mean by that is I want to get the absolute value all by itself on one side of the equal sign before I even begin to set up my question. So if I look up here at number 1, the absolute value of x equals 2. Is my absolute value of x all by itself with nothing on the outside of it? It is, okay. So then the second thing you're going to do after you isolate that absolute value is you're going to set up 2 equations. And the reason we're setting up 2 equations is we think about a number line, bless you. Think about a number line. Hold on 2 seconds. For every number that is 2 units away from 0, there is also another number that is 2 units away from 0, and it's the negative one, right? So what we have to do is we have to take into consideration each one of those values that have a distance of 2 from 0. So my 2 equations are going to look like this. I'm going to drop my absolute value sign, and I'm going to set at x equal to 2. And then I'm also going to set x equal to negative 2. And once we do that, then what we're going to do is we're going to solve each equation for x. And then lastly, we're just going to check and make sure it's going to be a valid answer. And I'll talk to you more specifically about when it could not be a good answer. Oh, sorry. Get in my way. So I got the absolute value by itself, which it already was. I set up my 2 equations, and then I can solve for x. Do I really need to do anything to solve for here? No, okay, they're both already solved for. And then my check is I'm just going to go back to the original equation. I'm going to plug in both of my values and make sure it gives me a true statement. So if I plug in positive 2 here, does positive 2 have an absolute value of 2? It does. Then I plug in negative 2. Does negative 2 also have an absolute value of 2? It does. So I have 2 answers here for this absolute value equation, 2 and negative 2. And you don't have to write x equals both of them. You can just put 2 and negative 2. Or you can write x equals 2, comma negative 2, or you can write it separately like that. Ready? Okay with that? Okay. Then the next one, number 2, says the absolute value of x is equal to negative 2. Again, isolate our absolute value, which it is. And then we can set up 2 equations, but does anybody see a trigger as to what the problem is at this moment? You can't have a negative distance. So if you ever have an absolute value of whatever equals to a negative number, that's not possible. You can't have a negative distance here. So even if I were to do this, and I'm telling you, if you can recognize it from the beginning, you don't have to. But even if I were to set up both of my equations, x equals negative 2 and x equals positive 2, when I plug those back in, does the absolute value of negative 2 equal negative 2? No, because you can't have a negative distance. So that one is no good. Does the absolute value of positive 2 equal negative 2? No. Again, we can't have an absolute value that's negative. So since neither one of those work, what would we put in this case? No solution. Okay. So just be very careful. If you notice where it's just the absolute value equals a negative number, that's automatically going will be a no solution because that cannot happen because we cannot have a negative distance. Make sense? A little bit. All right, let's take a look at 3. I'm going to do 3 with you, and then I'll let you try 4. This time we have a little bit more going on, but the process is still the same. We want to make sure the absolute value, whatever's inside of it, is okay, but there's nothing outside of it. There's nothing multiplied by the absolute value, nothing added to or subtracted from it behind the absolute value. Is that absolute value all by itself? It is, okay? So it's the absolute value t minus 3 is all by itself, and that's equal to 2. So then I'm going to set up 2 equations. I'm going to take that stuff inside the absolute value bar, and I'm going to leave it just like it is. I'm just leaving the absolute value bars off. I'm going to set it equal to 2. But then I also have to think about what other number has a distance of 2 from 0, and that would be negative 2. So we're going to set that up as t minus 3 equals negative 2. If you notice, I don't change anything other than losing the absolute value bars, setting it equal to the number it gives me, also setting it equal to the opposite of the number it gives me. And then I just solve each one of these equations, and we're just going to do a mental check to make sure it works when we're done. So I get 5. And I get 1. So if I plug it in, I'm going to plug in both of them. I'm just going to write it down. You don't have to if you can do it mentally. What's 5 minus 3? 2. Does 2 have an absolute value of 2? It does, so that one works. What's 1 minus 3? Negative 2. Does negative 2 have an absolute value of 2? It does. So both of those are valid answers, and we can put them both in the answer blank. So we get 5 and 1. Anybody have any questions? All right, go ahead and try 4 then. Make sure your absolute value is all by itself first. Then set up your 2 equations, what is inside the absolute value bar equals the number in the problem, and then also the opposite of that number. Is my absolute value all by itself in this equation? It is. So we're going to set it up. P plus 7 equals the number it gives me. And then also P plus 7 equals the opposite of the number it gives me. Then we're going to subtract 7 from both sides. And then we're just going to do our check. And again, you don't have to write the check down, just do it mentally. If I plug that P in, what's negative 4 plus 7? 3. And does 3 have an absolute value of 3? It does. Then I plug in negative 10. What's negative 10 plus 7? Negative 3. Does negative 3 have an absolute value of 3? It does. And so those are both my answers. A little hint. If you don't have a variable that's not inside the absolute value, all my variables are inside the absolute value, your answer should work, unless it's equal to 8. It's when we have a variable that's outside of the absolute value that it may cause us to get an answer that won't work. So that's kind of a hint on when you really need to check, is if there's a variable that's somewhere in the equation outside of those absolute value bars. Everybody okay with that? Say that one more time. All right, go ahead and try both of those. And then we'll get into some where we have to do a little bit more work. Remember, absolute value has to be by itself before you set up your two equations. And one thing that happens a lot on the test with this stuff is people always forget to set up that second equation. Okay? Anytime you have absolute value, you're going to have two equations to deal with. When we get to the inequalities tomorrow, it will be two inequalities to deal with. You've got to remember that every number and its opposite is the same distance from zero, so we can't forget that second equation. Are both of my absolute values all by themselves in both of these questions? Yeah. All right, so we're going to set up our two equations. Again, we don't change what's inside the absolute value bar. The only thing we change is the number it's equal to, and we set it equal to its opposite. We're going to subtract 2. Can I leave my answer as a negative y? No. So I need to divide by negative 1. So I get y equals negative 9. And then we're going to do the same thing here. Again, we don't want to leave a negative y. So I get y equals 13. So I've got negative 9 and 13. And again, just plugging it into check. However, there is no variable outside of the absolute value bar, so both of these should work. But if I plug in a negative 9, what's 2 minus negative 9? That is not what it is. What'd you say? 11. And does 11 have an absolute value of 11? Yes. And then if I plug in the 13, what's 2 minus 13? Negative 11, which also has an absolute value of 11. Again, so they both work. And then the same thing with number 6. It is already by itself, so we're just going to take the 5x and set it equal to 50. And then we're going to take that 5x and set it equal to negative 50. And we are going to divide both sides by 5. So x is going to equal 10, and x is going to equal negative 10. Plugging it back in, 5 times 10 is 50, which has an absolute value of 50. And then 5 times negative 10 is negative 50, which also has an absolute value of 50. Pretty easy stuff. Okay. Is everybody good with those? Let's skip 5, except for it should be 7, right? Let's skip that one. I want to go to this one. I don't know how I misnumbered that, but so I've got the absolute value of x plus 3. And then behind that, I have a minus 9 and then equals 2. So the first step that we haven't come across yet is to isolate our absolute value. This time, my absolute value has 9 subtracted from it. So before I can set up my two equations, I need to get that absolute value by itself, which means I would do what? Add the 9 over. Yep. And so I get the absolute value of x plus 3 equals 11. Am I ready for my two equations now? Bless you. Yes. So we do x plus 3 equals 11. Then we do x plus 3 equals negative 11. I got 8 and I got negative 14. And again, plugging it in to check. It's going to work because my x is inside of the absolute value bar. There is no other x that would cause me to have an issue here. Is everybody okay with that? Okay. This will be 8, not 7. Okay. Write that one down. We'll talk through this one. There is a mistake that people make on this one. Sometimes it works out okay anyways, but sometimes it does not, so you have to be very careful with this. So this one says 2 times the absolute value of 1 minus x, and then it's minus 4 equals 2. There are 2 things that I need to get away from this absolute value first. If that said just 2x minus 4 equals 2, what would you do first? Add the 4. Okay, so that's where we're going to start. Is we're going to add 4 to both sides. Is my absolute value by itself yet? No, I have that 2 on the outside of it that is being multiplied by that absolute value. So therefore, we need to get rid of that. And how do you undo multiplying? Divide. So we're going to divide both sides by 2. All that does is cancel that out. Okay, that 1 minus x is still the same inside the absolute value bars. And now we can set up our 2 equations. So I'm going to go 1 minus x equals 3. And then 1 minus x equals negative 3. And when we work both of these out and solve them, I get x is equal to a negative 2, and I get x is equal to a positive 4. And again, no variable outside of the absolute value, so therefore it is going to work. Let me... I want to show you this, okay? Just so that you kind of have an idea. Do you see how I have a variable that's not inside the absolute value? So we would do exactly the same thing. The absolute value is by itself, and you don't have to write this down. I just want to show you. I set it equal to 2x, but I also have to set it equal to negative 2x. So, do you see how in this one I get an x equals 2 and an x equals negative 2/3? Well, the 2 works. 2 plus 2 is 4. 2 times 2 is 4. Absolute value of 4 is 4. However, if I plug that negative, and I should have had an easier number, but when you plug in the negative 2/3 here, that gives you a positive number. That's going to give you a positive, what, 1 1/3? So, 4/3. But when you multiply, 2 times a negative is going to give us what kind of number? A negative. It'll be a negative 4/3. Does 4/3 have an absolute value of negative 4/3? Okay. So that's when the situation is going to arise to get a number that's not going to work. And that's only if you have a variable outside of an equation. It doesn't always give you one that won't work. It's just sometimes. So if you see that, that's your trigger to check your answers. If you don't have a variable outside, like all of the ones that we did together, they don't have variables outside. So really, you don't have to check because they're all going to work. Does anybody have any questions?